Hi, good morning. This is Jagdish, Assistant Professor of EC Department, SNS College of Technology, Coimbatore. Today we are going to discuss about the conventional power loop design. Now let's get into the topic. So, engineers have done PCB layout for many years and summarized some main areas of concern, among which the power loop is placed worth considering. So, how to do the power loop in PCB design? So, not only the power loop, and whenever the PCB is considered, printed circuit board is considered, there are various effects which is produced. This is unwanted effects. Like in the previous video lecture series, we have discussed about the parasitic capacitance and parasitic inductance. So those effects were minimized with some useful techniques. So likewise, the conventional power loop, the power loop design is very important for PCB considerations. So that means how it can be achieved that we will see. So the most important part of the power board is to bear the power circuit. When laying out, you should first know the circuit characteristics of the power part. The power circuit is mainly divided into dI by dt circuit and dV by dt circuits. That means dI by dt, that is difference in current with respect to difference in time period. And also dV by dt is nothing but of difference in voltage with respect to difference in the time period circuit. The layout of the two lines when walking different. The dI by dt circuit is relatively large when the current changes per unit time. So this part of the circuit should be as small as possible for loop area of the entire circuit. So though we have dI by dt and dV by dt, the dI by dt circuit have a large when compared to the current changes per the unit. So this should be considered mainly. And the voltage change of dV by dt circuit in unit time will be relatively large, which is easy to cause external interference. Therefore, the copper skin of the circuit should not be too wide in the loop. So it is different when the bearings current is satisfied and the copper skin width is as small as possible. The layer overlap area is as small as possible. The line of the driving part should first consider the area of the entire driving ring as small as possible to keep away the interference source and driving part as possible. The sampled signals must avoid interference with other signals as much as possible. If possible, the sampled signals can be sampled differently and complete ground plane is given to them to the corresponding wiring positions. So here the image represents here the it is nothing but a typical half bridge building block parallel plate shorter transmission line. So the image A represents the half bridge layout employing low impedance transmission line as power loop structure with corresponding dimensions, and the B edge view of same, and C is image is nothing but of the front view. So the circuit is placed in left side of this one is the circuit diagram, and the physical view which is represented in the three diagrams A, B, C. So here the power loop layout considered here is the half bridge configuration around which most power conversion layout are built, comprising two power semiconductor switches and a bypass capacitor as shown in the figure. The inductor L averages the output voltage level of the switch node VSW equal to V low, and the capacitor CHF, while in theory not required since it is parallel with V high, is required in practice to provide a low impedance path for high frequency currents. So in this figure BCD shows PCB implementation of power loop. In summary, a PCB layout should minimize the length and thickness while increasing the width. So this is the most important things. Whenever the width of the PCB is increasing, we have to minimize the length and as well as the thickness of the PCB. This can be accomplished by placement used in the layout of figure C, where length L and width W are determined by the physical dimension of the components, and T, capital small letter T, is the set by voltage requirements of PCB manufacturability constraint. Thank you.